In this video, we will see dry run of the code. So now let's do a quick dry run here. So here in this lis function, right? I have this lis function. Inside this, I am returning this lis, right? So my function lis here, this length of lis, here then my function is lis. So before that, I am simply saying n equals to nums dot length. So here n equals to 3. And dp is array of n, right? So basically we have n rows, so that means n is 3 rows and n plus 1 columns, right? So I have n plus 1 columns. Basically this I am taking n plus 1 columns because here I am using two variables, index and last, right? So my last is starting from -1. I am just changing its -1 to, basically I am changing from -1 to 0, and so that I will change n to n plus 1. So that's why I'm taking this. But although I guess most probably we won't reach to this n, right? So we don't, I guess, require of this extra column. But because I'm changing from -1 to n, so -1 is changing to 0, so n will change to n plus 1. Okay, so now let's see, right? So I will do first my function call lis, and I will say my lis basically is suppose L function, and I'm calling L with, I won't write nums, basically I will use two pointers, basically two pointers, index and -1. So I will call 0 comma -1. Now first I will call 0 comma -1. I will come to here, I will check is index is equals to n. No, it's not, right? So what I will do, I will simply move ahead, and my index point is at here at 0. So instead of index, let me say I. So my I pointer is at 0, right? And that is not equals to n. So my last index will be last plus 1, right? When it is complete, like when it will store in DP. So that's a DP thing. I will simply say it will be a DP thing. Let's move ahead. Whenever we need to fill it, we will fill it, right? So here, if DP of index is not equals to -1, then we will return DP. But here, this function, right? Like here dp of index, basically what is index? 0 comma -1. Last index is changed to last plus 1, so last is -1. Last index will be -1 plus 1, that will be 0. So 0 comma 0 is not filled yet, right? We have filled with -1, so all these values are -1, right? So this, it will not change our answer. I will simply move ahead, and I will say I will take the not take, right? So suppose I have, if I'm not taking it, that means I will say 0 plus again one function call, with index plus 1. So index will be index plus 1, so it will be 1, and last will be same, would be 1 comma -1. My I pointer will be here. Now I will check here. First what I will do, I will first now execute this function, right? Because this is a function call. So I will first execute this function. Again I will come here, is index is equals to n? No, index is not equals to n. So I will again come here, last index will be last plus 1. So here it will be last plus 1, it will become, last is still -1, it will become 0, but it will become 1 comma 0, still -1. Again one function call, so I will call this again function. It will be 0 plus L of 2 comma -1, right? Now again there will, again I will check is index is equals to n. No, index is not equals to n. So what I will do, I will check if it is stored in dp. No, it's not. Again I will calculate length will be again 0 plus again one function call, it will be 3 comma -1. Now when is 3 comma -1, my index is reached to 3. Now I will say is index is equals to n. Yes, so I will return 0. So here the value will be, returning value will be 0, right? So this function will return 0, right? So now once I have returned 0, right, I will get a length of 0 here. Now I will check is my last, this function is return 0, right? So basically I will say that here I am getting 0, I will return 0. Now I am getting here 0, right? 0 plus this function call. So here I will get 0. but I will first complete this function. This is not completed yet, right? So I have executed this one. I will check, is my last is equals to -1? Yes, it is. Then I will do a take call, and take call again one function called 1 plus lis, so L of index plus 1. So index will be 3 and it will be say index. So index plus 1 and your last will be your index. So it will become 3 comma 2, right? So I am calling 3 comma 2, right? So again, now let's first execute this function. So if I am saying index is equals to n, yes, it is equals to n. So it will return 0. So this will return 0. So one, if this is returning 0, I will simply put in the take and I will get maximum of length and take. So maximum of 0 plus 0, right? So here this is not, it won't return here. It will see 0 plus 0. This is a not take call when you are not taking it. This is a take call, right? Maximum of it 1 plus 0 and 0 plus 0. What is maximum? Basically the maximum will be 1, right? So what you will do, you will come here, you will store in dp. So in store you will store index and last index. So you will store 2 and last index will be -1 comma 0. So 2 comma 0 you will store the maximum, that means 1. So you will store 1 and you will return length. So you will return 1 to here, right? Now once you have returned 1 to here, it is 0 plus 1, right? This function call, you will again come to here and you will check if your last is equals to -1. Yes, it is. You will again do a function call. And you will take it. How you will take it? Basically you will say 1 plus L of, you will move to the next 2 pointer and your, basically you will move to the second index and your index will become 1, right? So basically let me give you a broader picture. Basically what is happening, suppose you are not taking 1, you are not taking 0, you are not taking 2 and you are getting out from it, so you are getting a length of 0, right? Now but suppose if you are taking 2, so you will take 2 and you will move forward. So here you are taking 2 and you are moving forward. So if you are taking 2, this is the thing. If you are not taking 2, this is 0, right? So 0 plus 1, which is greater, that means taking 2. You will take 2 and your length will be 1, right? So you have taken 2, right, from here, right? Now suppose like here you are not taking 0, that's why you have taken 2. Suppose you are taking 0 as well, right? So if I am taking 0, I have a call of should I take 2 or not, right? So I have 2 and 1. Again I will check. I will first execute this function, right? So let me call this function a bit more here, right? I will call this function here 1 plus L of 2 comma 1. Now when I'm calling this function, I will first execute this one. Is index is equals to n? No. Last index will be last plus 1. So we will calculate this later. dp of index of last index. So basically 2 comma 1 plus 1, that is 2 comma 1 plus 1, that is 2 comma 2. Is it defined? No, 2 comma 0 is defined, but 2 comma 2 is not defined, right? Basically it is not defined. So what I will do, I will say I will come to here and I will calculate if I'm not taking it. So first, if I'm not taking it, again it will be 0 plus L will call with 3 and it will be 2, right? So if you are calling with 3 and now you will execute this function and index equals to n. Yes, it is equals to n. I is equals to 3. So what you will do, you will simply return 0. So here you will 0, right? Now once you get 0, you is going to return, then you will again, right, then you will again call this function. Why you call this function? Let's see now, right? How I will get a call. Is last is equals to -1? No, it is not. Is num of index is greater than num of last? So let's check num of 2. So nums of 2 is 2, which is greater than nums of 0. Yes, 2 is greater than 0. So you will take a call and you will say 1 plus, okay, lis, you will take 3 and this will be 2, right? So you will execute this 3. You have reached to the last index. Yes, index is equals to n. So you will say return 0, right? So 1 plus 0 will be 1. And here you are getting 0. What is maximum? 1. So you will first store it. You will store it at index and last index. Index is 2 and last index will be, basically your last index will be 1 plus 1. So 1 plus 1, 2 comma 2. You will store this 2 comma 2. You will store this. What is the length? 1. So you will store here. Let me white pen. You will store 1 here, right? So this will be 1. And what will it will return 1. So what this length? 1 plus 1, 2. Here this length is 1. Again you are checking the maximum, right? So here if you are checking maximum, 2 and 1, which is max? 2. So you will return 2 to it. So you will return 2 to it. Okay. So once you have returned 2, okay, again it will check. You have returned 2. So first you will fill it. So 1 comma minus 1, 0. So if I say 1 comma 0, that will be 2. So this will be filled with 2. Right. Now you have done with this function. You will come here and you will check is last is minus 1. Yes. So again you will do a take call. Right. What will be a take call? That is 1 plus lis, right? 0 comma minus lis, and it will be index plus 1. So index plus 1, it will be 1, and it will be this index, so 1 comma 0. So now basically you have taken 1 and you are counting for this 0, right? So will you take it or not take it? So again the same series that we have done will come here with this one, right? So basically you will run this one, you will run this one, and you will eventually get the result, right? But here by doing this, so because here you are taking 1, right, but you are not able to take 0, so you will either take 2 only, the only option. So by this path also, when you are taking 1, okay, by this path also you will get maximum 2 only. And then what is the maximum? 2 and 2 both are equal, right? So you will store 0 comma minus 1 as 0 comma 0, and this will stored at, basically this will stored with 2 only, right? And that's maximum longest increasing subsequence will be 2. So that can be either 0 comma 2 or 1 comma 2, right? So that is the maximum length of the subsequence, and that we are getting 2 here. So basically what we will do, we will return 2 here, and that will be our answer. So basically, yeah, it was a bit complex, right? So but you will, if you will do a dry run, you will get this eventually, right? So don't need to worry about it, but you just need to create binary tree. See, I have chosen very smaller example, 102. Even for this example, I need to create so many tree diagrams, right? So it will be very, very, very long if you are taking a long example. Try to start with the shorter ones. Okay. Now let's quickly again discuss the time and space complexity. What will the time complexity here? Right. So basically what I am doing, I am just starting from this and checking all the possibilities, right? So 0 comma minus 1, 1 comma minus 1, 2 comma minus 1, 3 comma minus 1, 3 comma 2. I'm checking all the possibilities, right? So it will be all the possible combinations with two numbers, index and previous. So it will be, we go of n square, right? Because this will reach to n, this will reach to n, right? And space complexity. So this memory, DP memory space complexity will be n square plus call stack, right? This your call stack, this function call stack, right? So 0 to n. So it will also have n function calling, right? So time complexity big of n square, space complexity big of n square plus n. That will be your approach for longest increasing subsequence. So that's all for this problem. Thank you. I hope you enjoyed this video. In the next video, we will talk about more DP problems.